Storage infrastructure has always meant two things: lots of hardware and lots of work. And every new office is just one more headache. Managing mismatched hardware across multiple sites is the kind of soul-sucking tedium that could push IT over the edge. Now, the logical solution is to outsource your storage. But giving someone else full control of your important information and letting performance suffer just to go to the cloud doesn't seem like a logical solution at all. At the end of the day, you can't afford to screw this up, and downtime isn't an option. Well, what if you could have data storage as a service, keep full control, and local performance? With Nasuni, you can. Using crazy complex technology, Nasuni has figured out how to take on-premise hardware and combine it with the cloud to give you everything you expect from storage infrastructure. Except it's not what you expect. By simply installing a small controller at each site, you get an insanely powerful system delivered on the spot. Nasuni has figured out how to standardize your storage without IT giving up control. Every user at every office gets the same enterprise-class experience, along with some features you'd never be able to add yourself, like unlimited backups, infinite scale without adding hardware, and complete disaster recovery in less than 15 minutes. And as part of the deal, our team of super genius engineers constantly monitor everything. Now, downtime is a thing of the past. So, save yourself some work. Stop throwing hardware at the problem and get better infrastructure as a service with Nasuni. Learn more at nasuni.com.
Hypervisors allow multiple virtual machines to run on a single physical host and mediate all I/O operations, including read and write requests. A centralized storage array, such as a SAN or NAS, is typically used to provide shared storage for all of the VMs. Nutanix takes a different, much simpler approach. Its converged architecture incorporates local direct attached storage for faster performance and greater flexibility. Each node in a Nutanix cluster includes flash-based storage to deliver massive IOPS for high performance, as well as hard disk drives for low-cost, high-capacity storage. Adhering to the principles of a software-defined solution, Nutanix implements all control logic as a software-based service. A virtual storage controller runs on each node in the cluster, improving scalability and resilience while preventing performance bottlenecks. With storage and control logic now local to the guest VMs, there's no more need for expensive centralized storage or dedicated storage networks. The Nutanix distributed file system aggregates local storage across all nodes, creating a single storage pool that can be partitioned into one or more data stores. These data stores are then presented to the hypervisor, using the standard NFS protocol to provide storage for all hosted VMs. Because the hypervisor communicates to the Nutanix software exactly as it would a traditional storage array, there is zero change to the virtual environment. VMs are provisioned and managed as before, but without having to configure LUNs, volumes, or RAID groups. Now let's look at how Nutanix manages a typical write operation. When a guest VM needs to write data, its request is passed to the Nutanix controller, which then executes the write to local flash storage. It's also important to fully protect data so that it is always available, even if a node fails. To ensure the strongest protection, data is replicated synchronously across multiple nodes. For a typical read operation, requests are served by local storage resources. Keeping data local to the VM provides the fastest possible performance. That means for the majority of read requests, data never traverses the network. With many enterprise workloads, the older the data, the less frequently it is requested. When data becomes cold over time, it is migrated from flash memory to more economical hard disk storage. However, if that cold data at any point becomes hot again, meaning it is requested more frequently by a VM, Nutanix automatically promotes the data back into flash for the fastest possible performance. What happens if there is a node failure? Nutanix supports standard high availability capabilities, such as VMware's HA, so a VM will automatically start on another node. If that VM then needs to read or write data, it sends its request to the local Nutanix controller. If the data being read is not local, the controller determines where replica data has been placed and forwards the request to the correct Nutanix controller. The data is then sent back to the local Nutanix controller over a standard Ethernet network. The local Nutanix controller passes the data to the VM through the hypervisor and stores it locally for future access. At the same time, the Nutanix software once again replicates the data throughout the cluster in order to return the full cluster system to a fault-tolerant state. Each Nutanix node runs independently and leverages the Nutanix distributed software architecture to create a completely unified cluster. The Nutanix virtual computing platform integrates as many as 4 independent nodes into a space-efficient 2U appliance. For more overall cluster capacity, nodes can be added seamlessly one at a time with 0 downtime. With Nutanix, you can start small and easily expand to achieve truly massive scale. It's perfect for nearly any virtual workload, including virtual desktops and end-user computing deployments, private cloud projects, big data applications, DR initiatives, and more. Nutanix, the virtual computing platform for software-defined data centers.
This is Stu. Stu is a storage administrator. Stu's really good at what he does. In fact, in the world of storage admins, Stu rocks. Stu works for a big company. Ever since Stu's company started down the virtualization road, he'd been struggling to keep up with demands. Stu frequently got calls from the server administrators demanding storage for more virtual machines. They didn't understand how hard it was to provision and manage storage not equipped to deal with virtual machines. Without VM-level visibility, Stu couldn't locate virtual machines across all the LUNs and volumes. Stu was flying blind. He couldn't tell if the latency was coming from the storage, network, CPU, or somewhere else. And important tasks like snapshotting, cloning, and LUN or volume replication took a long time. Stu would hear from users too. Most of the time, they'd complain about poor email performance or some other apps being too slow. Since Stu needed to keep the performance up, he would over-provision storage, which added cost, space, energy, and more work for him. Stu was tired of being seen as the bottleneck. He couldn't face asking the CIO for a larger budget to buy more equipment and keep running storage the same way. There had to be a better way. Stu wished he could have storage that understood virtualization, which would reduce management complexity and deliver high performance without over-provisioning. He proclaimed, "I need VM-aware storage." This inspiration led Stu to Tintri. Now that Stu is using Tintri, the virtual servers and storage are finally speaking the same language. Instead of dealing with volumes and LUNs of complex multi-tiered storage, Tintri maps directly to the VMs and vDisks. It's so simple. The device goes from box to running VMs in 30 minutes. Since VMs are visible, a Tintri dashboard shows Stu important stats like IOPS and latency. A gauge tells Stu the actual performance usage and how much performance is left for him to add more VMs. Stu has instant VM bottleneck visualization to pinpoint performance issues, down to the specific VM level. He can also figure out whether the latency is caused by host, network, storage, or other elements. Snapshotting, cloning, and VM auto-alignment are a piece of cake. Stu can create hundreds of clones to support VDI and test development environments in minutes, instead of hours or days. With Tintri, over-provisioning is history, which reduces hardware, rack space, power, and cooling by as much as 2/3. Tintri had taken Stu from presumed guilty to free and clear. Everybody's happy that they're getting lightning-fast flash performance at disk prices. Stu became more than just a storage admin who rocks. He became a VM-aware admin who really rocks.
Virtualization in the data center has driven enormous efficiencies for servers, but storage hardware has remained inefficient. Data centers still have many silos of proprietary storage hardware that don't talk to each other and waste capacity or performance. Storage capacity requirements are growing by 40% every year, meaning that you have to buy twice the storage every 2 years. That's twice the storage to purchase, management, power, cooling, and maintenance. You need a new approach to storage. Stop trying to solve storage problems by throwing more hardware at it. Storage is software now. Introducing Atlantis USX, software that virtualizes storage in the same way that servers have been virtualized over the last 10 years. Atlantis USX abstracts all types of storage into high-performance storage pools, including shared storage and local disks. Atlantis USX doesn't just abstract and pool storage, it also makes them faster, cheaper, and more reliable than ever before. The secret is Atlantis USX Hyperdupe content-aware data services that increase the effective storage capacity and performance by up to 10 times. With Atlantis USX, you create virtual storage volumes and the performance, capacity, and availability required by your applications. You can instantly create an all-flash array, hybrid array, or hyper-converged storage with the push of a button using your existing server and storage resources. Scaling capacity or performance is as simple as adding more server or storage resources to the pool. Only use what you need when you need it. In the typical data center, 100 terabytes of storage needs will grow to over 500 terabytes over the next 5 years. After installing Atlantis USX, however, you'll reclaim up to 90% of that storage. You get an instant increase of 400 terabytes of effective capacity at a savings of $4 million in storage costs over 5 years. With Atlantis, you will get the performance of an all-flash array at half the cost of SAN. Join the revolt against those in power that have held the storage industry captive. Harness the power of software to conquer hardware limitations and those that restrict the new order. Try Atlantis USX in your environment today by clicking on the free trial button.
You respond in times of need and stay until the job is done. You've built the framework for success and will stop at nothing to keep business running smoothly. At Riverbed, we help you operate at your highest level with real IT solutions for real-world business problems. Wherever you need to send and receive information, whatever network visibility you need. However you choose to manage and protect your data. We increase the performance of the systems that deliver it. Do business faster, smarter, better with Riverbed. IT performance for your globally connected enterprise.
Kemp Technology's primary focus and purpose is application delivery technology, and specifically application delivery controllers, or ADCs. But what exactly is an application delivery controller? That's a great question. The typical IT administrator wouldn't know what that term means most likely. they do know the term load balancer. So what's the difference between a load balancer and an ADC? Is every load balancer an ADC? No, not all load balancers, certainly not the ones from a decade ago. However, every ADC is a load balancer. It's a more evolved, smarter load balancer that not only splits traffic across pools of servers, but also has advanced features like content switching that enable it to go a few steps further to monitor the application and make it perform better. And that's where Kemp's focus is, on the application. ADCs serve as a single connection point to multiple servers. They talk to all of the servers that they're in front of in order to check on their health performance and how busy they are. They also look at exactly what the end user is asking for when they ask for a connection. With this information, the ADC can make sure that each client request goes to the best possible server for the job. Since all communication goes through the ADC to the servers and then back through the ADC to the end user, ADCs are in a great position to gather information about how applications are performing and how users are using the application, and then provide this to other management and monitoring systems to give a consolidated view of how the application environment is working. ADCs are also interested in security, and they're so close to the applications that they service that they're practically family. They check every incoming connection first to make sure that what's being asked for is A-OK, and that the person asking for it is actually authorized. They also help to ease the responsibility of servers that are using secure socket layers, like your bank website does for security purposes, and they do this by handling the SSL processing, which can require a lot of work from the CPU. All of these features work together to make applications work better, quicker, and more reliably. Customers use this technology anytime they have applications that are important to them, that they want to ensure remains highly available and performing optimally, and to allow easy scalability as they need to add new servers to the applications. So before your head starts hurting, let's bring this back to the basics. Application delivery controllers are really smart load balancers. They do more than distribute traffic like a traffic light. They have a greater level of intelligence like a traffic officer, helping to ensure greater performance with regard to the applications. Kemp Technologies doesn't just make load balancers. That's so 90s. We make application delivery technology that's easily deployable in real time, anywhere, anytime, and on any platform. The best ones on the planet.
With its supreme ease of use and remarkably simple design, Lifesize Cloud has propelled the use of video conferencing in businesses around the world. Creating the perfect blend of hardware, software, and service, Lifesize Cloud provides a connected experience to anyone using room video systems, laptops, and mobile devices. In the meeting room, experience the award-winning Lifesize Icon Room Video System connected to Lifesize Cloud. It's easy to place a call with our shared directory or virtual meeting rooms. To add another person, just click on their name. You can even merge meetings with just a click. And remove individual participants just as effortlessly. Scheduling a follow-up meeting is easy. Simply send an email. You can even invite guests. There's also a way for participants to join via their browser. Do you need to reach a colleague to ask a quick question? Look in the directory to see if they're available. Start a chat. and call them over video. Sharing a document is just as easy. Your colleague can even resize the document. From the meeting room to the office and on the go, Lifesize Cloud delivers the connected experience.